Alright, we're looking at problem 151 here, and what we're going to do is we're going to model an oil slick spread out on a lake. So there's my lake, and I'll have an oil slick in the middle here. I'm going to try to visualize what's going on, get an idea for this. Now it says, if we read 151, that we have 1 liter or 1,000 cubic centimeters of oil is spilt onto a smooth lake. If the oil spreads out uniformly until it makes an oil slick just 1 molecule thick, with adjacent molecules just touching, estimate the diameter of the oil slick, assuming the oil molecules have a diameter of 2 times 10 to the negative 10th meters. So if I'm imagining the oil being these spherical molecules that are just touching, and my water is here underneath it, right? And this goes on for a long distance in either way. I have a height h that is just 1 molecule diameter. So the diameter of that molecule goes from the bottom edge touching to the top. So the height is going to equal 2 times 10 to the negative 10th meters, right? That's our height. Now, this is making a circle, and we want to find the diameter of the circle. And so we're going to get a cylinder that's 1 molecule tall. I worked in my undergraduate studies. We had a solid state lab, and we used a vacuum to layer gold. And we had some very high precision equipment to do this in. We were lucky when we would get 7 molecules deep of gold on a film. That was a very small film, and we were very lucky when we got down to it. Well, not lucky, but our technique was working really well when we got down to 7 molecules of gold. So 1 molecule of an oil is fairly small thing. So we think this is ultra thin layer. And surface tension and other things, in reality, an oil slick is probably going to be a couple molecules thick. But for an illustrative purpose, we're having this 1 molecule thick. It gives us a dimension of h. Well, it's a circle, and we're looking at a cylinder. So we're going to have a volume here coming out of this. And the volume is going to be the equation for a cylinder's volume, which is pi r squared times h. But we were also told the volume was initially 1 liter. So we know this is going to equal a liter of oil. So we kind of have our equation kind of set up for us nicely. It's just that h is really small. So this should assume that r is going to be very large. It's one of the things we can look for on this. But, whoops, sorry, that was very loud, but I didn't watch the microphone jump there. But what we can do is we can set up an equality with some unit conversions here. So I'm going to have 1 liter for my volume on the left-hand side. And I'm going to want to convert that to meters. So 1 liter, if I look on my sheet here, what is that? 10 to the negative 3 meters cubed. Make sure I'm looking at the right. Always keep these sheets handy here. So 1 liter is 10 to the negative 3 meters cubed. So I can set up my first conversion factor here, 10 to the negative 3 meters cubed divided by, that's a liter. So I've now gotten this into meters cubed. So on this side, I can set pi times 2 times 10 to the negative 10th. Negative 10th. There we go. Meters r squared. I know we're looking for diameter, but mathematically, r is easier to deal with, and we just remember whenever we get an r to multiply it by 2 to get our diameter. Again, a geometry thing that's going to pop out a lot. So I have a number on the left-hand side here in meters cubed. I'm going to divide it by this pi meter. So 10 to the negative 3 over pi. Why is my pi not writing? There we go. Times 2. Times 2 times 10 to the negative 10th. Pen is going through so many batteries on these pens, but I have like 2 of these, or 3 of these pens, and I suspect that I keep grabbing the one with a dead battery and having to replace it. My apologies, I'll get this all sorted. I'll get new batteries on everything soon. Meters, and this was meters cubed up here. So I'm going to get something in terms, and that's r squared. So I take the square root of both sides, and while I'm doing this, I will use my rules of exponents. So upstairs I have 10 to the 7th. Divided by 2 pi. Again, we're playing with algebra here. 2 pi 10 to the 7th divided by 2 pi, square root. Equals r. So I'm going to type that into my calculator. And I get, let's see here. Again, I'm working on getting a better on-screen calculator for you. But for right now, let's get this in here. 2 times pi. And take the square root of it, and I get 1.26 times 10 to the 3rd meters. Multiply that by 2 for my diameter. So say this is 1.26 kilometers. Roughly 2.5 kilometers for the 2.5 kilometers for the diameter. Round it to 1 sig fig. Round this all to 1 sig fig. And so my diameter is approximately 3 kilometers. And so again, we're looking at geometries and equating volumes. But in this case, we made a really, really small spread. And oil does do that. Oil does get down to only a few molecules thick. And so it can, a very little amount of oil can spread over a smooth surface of water. Choppy water changes the dynamic a bit, but and this is very important to know from environmental factors on how your materials react with each other, how much a problem you can have. A 3 kilometer distance, well, 5K is 3.1 miles, so 0.6 is about 2 miles. It'll be about a 2-mile diameter. To put it